All right, welcome back in this lesson. We're going to be focusing more on finding that real root, the rational root that we can use to divide into a polynomial functions ourselves. So instead of it being given to you, you're going to know how to find the root itself so that you can go ahead and divide the polynomial until you can get something that's factorable, or is in its simplest factored form, to find the other real roots. So it says here, given the polynomial p of x equals x to the fourth minus x cubed minus 5x squared plus 3x plus 6. List all of the possible rational roots that a polynomial could have. So all possible roots, those are going to be everything. It's going to have something to do with the leading coefficient and the constant. So I'm going to put all factors of 6 on the numerator, 1, 2, 3, and 6, all over the leading coefficient, 1. And it's plus or minus because they can either be positive or negative, because you can have two negatives that give you a positive. You can have 2 and 3, negative 2 and negative 3 to give you 6, positive 2, positive 3 to give you 6. You can get positive 1, positive 6 to get you 6, negative 1 and negative 6 to get you 6. And we know that the leading coefficient is 1, so this makes sense that these could all be possible rational roots for the polynomial, so when divided out, we can get plus or minus 1, 2, 3, and 6. Nothing really changes. And if we want to write them all out, negative 6, negative 3, negative 2, negative 1, 1, 2, 3, and 6. Those are all the possible rational roots that we can use to divide it back into. But we're going to find out that some of these might not exist, and we got to figure out which one works. And we've already done it in the previous lesson. So let's do B. Use your list of possible rational roots to make a list of possible linear factors in the x plus or minus a form that the polynomial could have. So we can have x plus or minus 1, x plus or minus 2, x plus or minus 3, and x plus or minus 6. Those are all possible linear factors that we can use to divide into the polynomial function. Is that a mouthful? But hopefully you guys are still with me. Use the remainder theorem to find the two of these possibilities that are roots of the polynomial. So remember what we did with the remainder theorem. It's P of C equals R, and to get a root of the function, R must equal 0. R has to equal 0. So that's what we want to know. We want to know for what C, which of these gives us equal to 0. Yes, you guys are going to have to plug and find it out. But lucky for you guys, I magically guessed and got 0 for both of my roots. How did I do that? I don't know. Maybe I'm just a magician, can do it all in my head. So negative 1 to the power of 4 minus 5 minus 1 squared plus 3 times negative 1 plus 6. And that gives us 0. Yes, check it in your calculator. Make sure I'm not fooling you. I could have just made it up. And the other one I found was P of 2 equals 2 to the 4 minus 2 to the third minus 5 times 2 to the power of 2 plus 3 times 2 plus 6, and that also gives us 0. So I found both of the roots that give me 0 for my remainder. Let's see, what do you think D is going to ask us? What do you think is going to ask us to do with these roots that we just found? Divide the polynomial by one of its factors so that it could be written as a product of a linear factor and a cubic factor. So what we did before, and we know that our linear factor is going to be x plus 1 if we want to use 1, and I want to use 1. So negative 1 for the first one. And let's bring down all the leading coefficients. 1, -1, -5, 3, and 6. Yay! All right, let's go. So we have 1, bring it down, 1 times -1, -1, we get -2. -2 times -1, we get +2. Add those, we get -3. -3 times -1, that's +3. Add those, and we get 6. So 6 times -1, -6. Oh, look at that. We got 0 for a remainder. And now it's asking us to put it in the product of a linear factor and a cubic factor. So let's write the new cubic factor. X cubed minus 2x squared minus 3x plus 6. That's one of our factors. And then it's asking us to a product of the linear factor. Well, what do we just divide out? X plus 1. There we go. That's the form I showed you guys in the last lesson. A form, not the standard form. That's a different form. Don't get those two mixed up. And there we go. That is our answer for part D. What do you think part E is going to ask us to do with the other root? Divide the cubic factor from part D by the other linear factor that you found for this polynomial. So your polynomial is written as a product of 2 linear factors and 1 quadratic factor. So let's get started. It's going to be x minus 2 because I found +2. So I'm going to write 2. 1, I'm going to use this, the cubic factor. 1, -2, -3, and 6. We have to use the cubic factor because if we go back and we do the original factor, we're still going to get a cubic factor. We haven't broken it down any further. We still have a cubic function. So let's do synthetic division. 1 times 2, so I'm going to add 2. Well, I already got a 0. 0 times 2, and some of you guys are thinking, so it's not going to work. Ooh, but you'd be wrong. -3 plus 0, you get -3. -3 times 2 gives us -6. Oh, look, we added and we got another 0. So let's write all of our linear functions first. So we have x plus 1. X minus 2, our new one, and now we have a quadratic factor. What is our quadratic factor? X squared plus 0x minus 3. There we go. That is our new answer. Oh, would you look at that? We have one more problem. E. What do you think E is going to ask, aside from reading it to yourselves? From the factor form, find all the roots of p of x. Oh, yes, and we've already factored it into a form where we could find the roots of p of x. X plus 1, x minus 2, x squared minus 3 equals 0. Now we can solve for x for each of them. X equals -1, x equals 2, and x squared equals 3. But wait, can't we break it down even further? Yes, we can. So we're going to square root both sides. We get absolute value of x equals square root 3. And to remove the absolute value, we get x equals plus or minus square root of 3. So what are our answers? We have 4, and it's to the 4th root. So we know that we did it correctly. The original polynomial is to the 4th power. My bad, not 4th root. And there we go. Those are our answers. All right, next page. It's gonna take me a little bit to set up since everything is a little unorganized. All right, let's get started. So, try finding all the roots. Well, I already showed you how. So x equals plus or minus, what's the factors of 7? 1 and 7, all over the leading coefficient. Factors of the leading coefficient, which is just 1. X equals plus or minus 1 and 7. Well, I guessed my first try and I got it right. Q of -1, I found that to equal 0. And I was right the very first time. Minus 7 times -1. Minus 7 equals, look at that, equals 0. So -1 drag down all the leading coefficients of the polynomial. And we bring down the 1. 1 times negative 1, and we get a 0 off the back when we add the second one. 0 times negative 1, we get 0, so we're left with negative 7. Negative 7 times negative 1, positive 7. We add these together and we get 0. So what is our new factor? We're going to get x squared plus 0x minus 7 times x plus 1. Right? Because negative 1 is still a factor. It's still a root. So what is the root? Can we solve for the root? Yes we can. So we get x equals negative 1 and x squared equals 7. So I'm going to square root both sides, and then I'm going to get the absolute value of x equals square root of 7. X equals plus or minus square root of 7. Now I'm going to highlight my answers. There we go. Good to go. Now, I'm sure you guys know that I'm gonna find the real root off the back, and you already know that it's plus or minus 5 and 1 divided by 1. So let's go. Let's do it. X equals plus or minus 1 and 5 for the factors of negative 5, and divided by the leading coefficient factors, which gives us plus or minus 1 and 5. Would you look at that? When I plug in 1, I'm going to get a 0. You guys can say no, but I'm going to be right. One cubed plus 3 times 1 squared plus 1 minus 5, and that gives us 0. So we're going to put 1. We're going to drag down all of those leading coefficients. 3, 1, negative 5. Oh, look at that, and bring down the 1 there. 1 times 1, 1, add those, and then I'm going to get 4. 4 times 1, 4, add those. I'm going to get, 5. 5 times 1, positive 5, add those, and I get 0. So what is my new function? So I'm going to get x squared plus 4x plus 5 equals 0. Well, not yet. X minus 1 times x minus 1, because x minus 1 is still a root. So let's do the easier one. X equals 1. There we go. How about x squared plus 4x plus 5? Are there any factors that we could break it down to get more? No. So do you guys want to use the quadratic function or completing the square? I'm going to complete the square. It's easier. So I'm going to do x squared plus 4x plus 5 equals 0. So I'm going to get x squared plus 4x equals negative 5. I'm going to take half of 4, 2, square that, add 4 to both sides. So I'm going to get x plus 2 squared equals negative 1. Then I'm going to take the square root of both sides. Oh, square root of negative 1. Where can I immediately change that to? An I. So I'm going to change that for the second step, equals absolute value of x plus 2. And then to get rid of the absolute value, x plus 2 equals plus or minus I. Subtract 2, x equals negative 2 plus or minus I. So I have x equals 1 and x equals negative 2 plus or minus I as my roots. And we've already gotten roots with I. Although they're not real roots, they're still roots for this function. Imaginary roots. And that's all it's asking. Try finding all the roots, which we did. There we go. Perfect. Let's move on. All right, it says, given p of x equals 6x to the 4th plus 7x cubed minus 36x squared minus 7x plus 6. What is different about this polynomial from previous polynomials in this lesson? Well, we have a 6 for a leading coefficient. So leading coefficient isn't 1. And here, the theorem that I've been using for the last few times, but it wasn't important because it was always divided by 1 because that was my leading coefficient. So it says here, if a polynomial p of x has an integer coefficients, then every possible rational root of p of x will be of the form p divided by q, where p is a factor of the constant term and q is a factor of the leading coefficient. And negatives do count. That's why it's plus or minus, because negatives are still factors of that term, even if it is positive or negative, because you can do a positive and negative to keep getting a negative from both ends. So p over q, and it says p is going to be all of the possible factors of the leading coefficient, and q is a factor of the leading coefficient. So we're gonna get a lot of factors for 6 and 6. So our factor is gonna be x equals plus or minus 1, 2, 3, 6, divided by all of the factors of 6, which are 1, 2, 3, and 6 again. So let's do it. So we're gonna get plus or minus 1, 1/2, 1/3, whoops, 1/6, and I'm trying not to repeat them. 2, and we already have 1, 2/3, 2/6, which is 1/3, so we don't need that. And now 3 over 2, 3 over 3, which is 1, 3 over 6, which is 1/2, we already have them. We can get 6 over 2 is 3, 6 over 3 is 2, and 6 over 6 is 1. So these are all possible rational roots. Now we have to plug them in. And we could put it in the x plus or minus form, in the linear form, but we don't really need to because there's so many of them. So these are all possible rational roots. It's for each factor. You see it says is a factor the constant, and q is a factor of the leading coefficient. So it's 1, it's all possible factors, all possible combinations of those factors. Don't get that confused. It's not just one. There are multiple, and these, we might have to plug in every single one of these to figure out which one of these gives us a 0, if one of them does give us a 0. But if I'm feeling sadistic, I might have you guys do that. But that's not going to be a requirement. That's crazy. You'll maybe need to test 2, and one of them will give you a 0. So, like in here, in the above, like a prime number. So let's continue to the last page. All right, so it says find all the roots of p of x, and I've put away the paper with the leading coefficients and whatnot. So just trust that I've memorized it. I have this amazing memory and not a cheat sheet next to me. So let's test p of negative 1/2. I'm feeling lucky. 6 times negative 1/2 to the power of 4 plus 7 to the negative 1/2 to the power of 3 plus 30, well, minus 36 to the negative, multiplied by negative 1/2 to the power of 2 minus 7 times negative 1/2 plus 6. And would you look at that? It does give us 0. So x plus 1/2 is one of those roots, factors. So then I'm going to put negative 1/2, put that in there, and then I'm going to drag down all the leading coefficients. 6, 7, negative 36, negative 7, and 6. So I'm going to bring down the 6. 6 times negative 1/2, negative 3. Add those together, you get a 4. 4 times negative 1/2, I'll get a negative 2. I'll add these together, and I get a negative 38. Negative 38 times 1/2 gives me 19. Add those together. 19 plus negative 7 gives me 12. Half of 12 times negative 1, well, negative 12 times negative 1/2 gives me negative 6. Add those together and I get 0. Would you look at that? Correct. So I'm not going to put it into its cubic factor because there's no need to. But now we get to test a different function to break it down even further, right? So I'm going to test p of 1/3. I'm feeling lucky again. I'm feeling 1/3 is going to be give me a 0. And you see how I'm plugging in it into the original, because the new function is going to have different things I need to test. But if x plus 1/2 is one factor for the original and x plus 1/3 is also a factor of the original, I know that x plus 1/3 is also going to be a factor of the broken down version of the polynomial function. Plus 7 to the 1/3 to the third power, minus 36 to the 1/3 to the squared, minus 7 times 1/3, plus 6 equals, oh, whoa, would you look at that? It also equals 0. So x minus 1/3 is also a factor. So let's go, let's do the math. To the 1/3 power, I'm just gonna bring these straight down because I don't need to worry about the leading coefficients because these are my new leading coefficients. And I'm not gonna include 0 because 0 disappears. So bring down the 6. 6 times 1/3, 2. Add those together, I get 6 again. 6 times 1/3 again, 2. Add those together, I get negative 36. Negative 36 times 1/3 gives me negative 12. Oh, and I get a 0. So let's put it into the new form. Not the new form. Let's put it into the like linear quadratic factor form. So I'm going to do x plus 1/2 times x minus 1/3 times 6x squared plus 6x minus 36. So I'm going to move the quadratic factor to the front so I can pull out a 6 and make it easier for me to factor that part even further. So I'm going to get 6 times x squared plus x minus 6 times x plus 1/2 times x minus 1/3. There we go. Can I factor that further? Yeah, I don't need to complete the square or use the quadratic function. X plus 3 and x minus 2 and x plus 1/2 and x minus 1/3. And I forgot to set the whole thing equal to 0 because that's how we find our roots. Real or imaginary, it doesn't matter. That's how we find our roots. I hope that was in the shot. If not, I am sorry. X equals negative 3, x equals 2, x equals negative 1/2, and x equals 1/3. Those are all of our factors, and all of them are real, and we don't have any double roots. I should have mentioned that earlier to get you guys going, remembering previous lessons. And those are all the answers for this section. Thank you, and I will be seeing you in the next lesson. For me, short amount of time. For you guys, an infinite amount of time.